every year recycle between, I would say, 9%, and it is getting less of plastic. So in general, overall recycling. But though the recycling grade of PET is relative, PET PET plastic used for bottles is a bit higher. So 9% of recycle, imagine 91% of plastic basically, generally speaking, ends up in the environment.
Hello everyone and welcome back to the CleanTechies Podcast. This is episode 64 of the show. I'm your host, Silas Maynor, and I'm thrilled to have the opportunity to bring this show to you and super thankful to you for tuning in. If you are interested in becoming a sponsor, you can reach out to me via our Slack channel or reach out to me via email directly. My email can be found in the description. And if this is your first time with us, please do subscribe and turn on notifications to join us on this journey. If you are a returning listener, please, of course, also give us a review if you enjoy the show, as evident by your return. That always really helps us to grow the show and get a lot more recognition on the charts. And if you are a founder in the space, as always, please feel free to reach out for anything that you might be looking for. We're always glad to make potential introductions to capital or other talent or whatever you're looking for. Just always glad to help, so feel free to reach out as well. With that, let's get into today's episode. So today we are joined by Bahruz Mammadov, we are discussing how he and his team at BERKM Inc. are helping reduce plastic usage through their innovative technology. So there are kind of two key areas where we really discuss today, a lot of nuanced topics, but the key things are how their additive allows bottle makers to reduce the total volume of plastic used in the creation of those bottles, which is actually pretty impactful once you apply it to a pretty large scale. And then how they are working to increase recycling in a full circle mentality with a circular economy in mind. There was also another area which I thought was also interesting, which was the way that plastic manufacturers kind of have a difficulty innovating given the high capex expenditures for their factories and their machinery. So a couple very interesting things discussed here. Very, generally speaking, the science is obviously quite complex on how this works, but kind of straightforward solution ultimately when you look at it from a high level view. So as always, though, before we get into the show, we do want to make special thanks to our sponsors, NextWave Partners. NextWave are experts in talent acquisition, recruitment, and retention across the climate tech, renewables, and ESG spaces globally. So if your team is growing or you're looking to make a career change, you can definitely reach out to NextWave at next-wavepartners.com or reach out to one of their consultants directly via their LinkedIn page. So without any further ado, let's get into the show. All right, Bahruz, welcome to the podcast. How are you doing today?
Great, Silas. Great pleasure to be here. Have been looking forward for this call.
Absolutely, likewise. I'm really excited to discuss this. I don't think we've really had anybody like yourself on the show kind of doing what you're doing. So I'm very excited. I guess for everybody listening, why don't we just start off by having you introduce yourself a little bit and maybe share a few of your kind of accomplishments throughout your career.
Yeah. So I have background in chemistry and material science. That combined with 12 years experience in the chemical industry. So I started my career in corporate world as a chemist, quickly grew up, but then I decided that I wanted to do more fun things and do entrepreneurship. So because I am coming from the family who is entrepreneuring 4 generations. So at present time, I am doing entrepreneurship in chemistry and material science, trying to combine my passion for chemistry and materials together with entrepreneurship DNA. So at present time, I am working on my startup project. Previous ones also go in material science space in Europe, also in US. So that's it about me. Couple of words about the company. At BERKM, we are working on solving several global challenges. One of them being plastic pollution. So what we do, we reduce the amount of plastic used per packaging up to 20%. We also extend product shelf life 6 times and more, and support recycling in several ways. So that was in a nutshell a couple of words about myself and the company, what we do here.
Yeah, absolutely. I think that's really helpful to kind of give us a quick context and the intro here. What I am curious about always, as I ask everyone, is how did you end up deciding to get into climate tech specifically?
So that's very good question. So it's a combination of market opportunity and personal DNA, the passion. So let's start with personal part of things. I grew up in a household which cares about sustainability. Just to give you a flavor, my mother is a sustainability manager at Bose before she was at IKEA. So I really grew up in this environment where caring for the community and the environment was top priority for us. So first time when I heard this opportunity, I said, okay, so these first boxes clicked my sustainability passion. Second point is that sustainability anymore is not like good to have, but it's becoming must to have. So I understood that this technology can improve bottom line of the companies while helping to reduce plastic pollution and food and beverage waste. So this combination of these two factors made me to join this journey I am in now.
Interesting. And then I guess one thing I'm always curious about is when you were deciding what to go to university for, did you have in mind this particular problem that you're currently working on that you said, hey, I could learn this so that it could help me in the future to solve this kind of problem?
I wish I had. There are a couple of points. I mean, I guess, the timing still really matters. Like when I go to college, what was that, 2004, right? I mean, almost 18 years ago. Wow, it has been a long time. The wave of sustainability not was that acute, I would say. So this is like the wave and the people starting speaking and paying attention to this. Really last, I would say 10, 12, 15 years, it's becoming more and more as we speak. So now, back in time, I like the chemistry. That was my passion. I dived in, and along the way, I figured out that chemistry turns out to be a big part of the sustainability, since everything we touch in our daily life is part of chemistry and chemical industry.
Mm-hmm. Yeah, I think that's interesting. I really find it fascinating how people end up kind of taking that journey into climate tech, and usually it's just not exactly necessarily their first thought when they're especially choosing their university path. So I think that's really interesting. Why don't we talk a little bit about, before we get into kind of the nuances of what the company is doing, could you speak to us a little bit on some of the statistics and the data around plastic usage?
Yeah, I mean, every year recycle between, I would say, 9%, and it is getting less of plastic. So in general, overall recycling, but though the recycling grade of PET is relative PET PET plastic used for bottles is a bit higher. So 9% of recycle, imagine 91% of plastic basically, generally speaking, ends up in environment. Plus, industry spends to make 1 pound of plastic, while different plastics are different. In general, you produce 1 pound of CO2 emissions. And for some plastics, depending on chemical manufacturing, is even more. And most of that, it's like ends up in landfills. So Great Pacific Plastic Island is 3 times of France, just to give you the size comparison. So that's how big is that, these plastic islands. Yeah, but the good side is that more and more recycling facilities are built, and we as a society started working on it.
Mm-hmm. And I guess, could you address some of I guess maybe we should get into the nuances of what you're doing now, but I'm just kind of curious to say, to recap, that it sounds like 9% roughly of plastic is recycled, which leaves around 91%, which is not. And then a lot of that is ending up in the environment. And what are the typical solutions that people look at to try to reduce this? Are they, I know there's a lot of people talking about reusable containers or potentially kind of going away from plastics as a whole. Could you maybe talk us through what you guys are doing in the nuance behind the chemistry here around kind of solving this problem?
Yeah, and the one point regarding recycling, I mentioned these statistics is regarding US. In Europe, especially countries like Germany, they're doing a better work in recycling, like a better work in recycling. So can you repeat the question? Sorry.
Yeah, absolutely. I'm just kind of curious to use this as a pivot to kind of how you guys are helping solve the solution. If you want to walk us through the process of what BERKM is doing.
What we do, we have a additive white powder, let's say additive, which gets mixed with plastic. So what it does in the first place, it increases material properties like gas barrier, ability to keep gas inside the bottle or package. Like if you ever wondered why your Coca-Cola or Pepsi tastes better in aluminum can or glass bottle, gas barrier property is one of the reasons, not only one, but one of the reasons. So glass and aluminum keep gas inside better than plastic. Plastic leaks gas. So that's one of the surprising findings I learned along the way. So we increase gas barrier property of that plastic, now focused on PET. The second, we improve strain of plastic. Speaking about why these two parameters, gas barrier, ability to keep gas inside of a package or be as a barrier to a gas, and strain important. Because obviously, if you have stronger material, you can use less of it. That's the first logic, right? Secondly, the ability of a beverage, Coca-Cola bottle, and given this cola as an example, is if you paid attention, what your still water is lighter, bottles are lighter than the carbonated drinks. You know, you can easily squash water bottles, but it is not that's easily squashable to carbonated. That's because they have to make the walls of the carbonated drinks thicker to be able to keep the gas inside, you know. So because we improve strain and gas barrier property of plastic, basically you can make the walls of the bottle, a package thinner, up to 20%. You cannot make it infinitely thin, obviously, but so we can reduce it in 20%, basically saying that eliminating every fifth plastic package. So that's basically our contribution. Then we also help the recycling in many ways. So making sure that there are more recycling cycles of plastic.
Mm-hmm. So generally speaking, to recap that, what you're doing is essentially editing the plastic making process, which is allowing it to be a better type of plastic, which can then reduce the thickness of it, which it ultimately is reducing plastic usage, correct?
Yes, you described it perfectly, Silas. It is still PET, but it is PET 2.0, you know, because if somebody comes and tells that, okay, I have a new material, which is better, these awesome, like lighter, degrades, biodegrades, but in reality, putting new market to the packaging industry, it's a hell of a work, and it takes decades. There are some materials out there which have some promising materials, but the industry have properties, but the industry is ignoring them because they have so much infrastructure. So my point is that if you want adoption rather quick, not 20 years, it is better to improve properties of existing materials in addition to getting new materials too. I don't say that we have to stick what we have with what we have, but it is faster path to have bigger impact.
Yeah, that's always quite interesting to me, is the adoption curve. So I guess, could you maybe speak a little bit about that, on what types of companies you're tending to work with, which companies are more open to this, and what are some of their common objections?
Main companies we are working are global food and beverage companies. Actually, this is not correct. Everybody who uses plastic packaging, from cosmetic guys, like I will not mention names, biggest cosmetic guys, to beverage makers, everybody who uses plastic packaging wants to talk to us, right? Because Why? Because we help them to meet their sustainability goals. You know, the sustainability is big topic nowadays. And also in parallel, it's not only about sustainability, we help them to improve their bottom line. So this is in terms of why they want to talk to us, who are our customers. And the common objection we are getting is recyclability. Because, for example, in terms of the environment improvements we provide for the packaging, there are alternative technologies. But one of the problem of that, of course, cost matters. We are cheaper, but also those alternative technologies harm recycling by creating this yellowish color, and you don't want your soda bottle to be yellow, you know, so that consumers don't like that. So the recycling was one of the first objections, sort of slash questions we get. Second one, adoption, in terms of like so all these PET packaging infrastructure, there are million and million in equipment investment, you know, right? So there are plants over there, working machines, people trained. And if you can't, it is not easy to go there and say, okay, you don't use this machine, you spend 10 million on this, you know, it doesn't work like that. So they want to make sure that the equipment you are using is compatible, the technology you're using is compatible with the present existing the equipment and so on. That's very important question we are getting. So, and then it comes to the performance, right? I mean, why you are better, how you are better, and this kind of things.
Mm-hmm. Yeah, I guess I'm kind of curious with that, you know, obviously having to overcome those objections, maybe we could walk through the various benefits of the product. So it sounds like, first of all, kind of reducing the amount required also reduces the cost. Aside from cost savings, what are some of the other benefits of using a product like this?
So other benefits are extending product shelf life. So for example, your favorite sandwiches in convenience stores or fresh cut beverages, you know, I like to buy fresh cut mangoes and the watermelons. They have 10 to 14 days of product shelf life. So what happens when you cut these guys? So skin is gone. Skin, one of the roles of the skin is protective layer, right? Protective layer is gone, then so it is easy to spoil. So when they package it in such way that they prevent oxygen entering to the package, because when oxygen is the bad guy. What happens, oxygen diffuses from the atmosphere to the package, spoils it, right, during these 10, 14 days. What we do, because again, we increase gas barrier properties, we can stop, we can reduce the diffusion of oxygen to the package, therefore extending product shelf life. So that especially matters for fresh cut vegetables, fruits, and this kind of thing, sandwiches. So that's the one. Besides cost saving, we help them to, again, extend product shelf life. Then again, meeting sustainability goals. Now, one of the challenges is all these companies made the public commitment, the brand owners, that they want to reduce the plastic waste consumption or somehow. Again, you use less plastic. It's one bonus point that, okay, you managed to reduce it, but also recycling. So these companies are under pressure to use more recycled content of the package, okay? So we help them to have bottle-to-bottle recycling. So what happens today, if you take a PET bottle, as you recycle it, Silas, the properties drop, like strain drop, gas barrier. It is not the same plastic bottle. So because we improve these properties of plastic, you recycle them more, even to make recycled bottle-to-bottle recycling. We are working on bottle-to-bottle recycling. It is not done. Basically, I say that we are trying to make a new bottle from recycled bottle. But what happens today, you take a bottle, recycle it, recycle it to carpet or some textile, you know? I say, no, don't waste it. Don't make it cheap stuff. Take a bottle, recycle it to bottle. So that's kind of the advantages we provide to our customers.
Mm-hmm. I'm always curious to ask this one, and again, it may not be in this case, but I'm always curious: are there any health benefits usually that you've noticed in the science from this type of plastic compared to others?
No, specifically, I cannot mention that if this
Yeah, that's fair. So I think the only thing that to potentially highlight on my end would be obviously better recycling and less usage is going to be better, less pollution, which is also better for health. But I'm always keen to ask that question because it's something that normally people don't think about. What other, I guess, what are the things you're noticing in the industry? You mentioned a little bit about the infrastructure and the difficulties surrounding making kind of big innovation steps. What are you seeing in the industry in general? Do you think that the people will start to make larger steps towards sustainability with other solutions that that don't necessarily fit into their existing structures? Like, what are you seeing as a whole?
That's a very good question, Silas. So the overarching point is that people are getting the companies, the brand owners, Pepsi's, Cola's, Nestle's, Unilevers of the world are more under pressure to reduce their plastic footprint. That's the main overarching point. Then the question is that how you do that, right? And there is no single answer to that. There is like you have different key sizes to solve the unscrew stuff, right? When you put IKEA together, you have several key sizes to put furniture together. So solving this plastic pollution also has many parts. So I will mention a couple. So first, improving existing materials. Like that's what we do. You use less of that. First, use less of that. Recycle more. Right. So the countries like Germany, somewhere I read recently, they have up to 90% of recycling rate of PET because they have the right incentives over there, right? So recycle more, right? This would be the second answer. And the good news is that more and more recycling facilities are built. So, and another good news is that turns out today, price of recycled PET is 2.5 times higher than virgin PET. So pay attention to that. It's a very interesting moment that if you take a trash from the cans in the city and put together 1 pound of PET and another clean pound of PET comes out of factory, your pound of PET more expensive. Is that because there is more demand for recycled content? Right, so we are getting better at recycling, but I feel that especially in US, we don't have enough incentives aligned. We need to align incentives. People have to get paid for recycling more. Use less of recycle. Then you have alternative materials. Like paper as a material is getting more and more attention. People taking the same paper, tweaking, adding different things to it and trying to improve certain properties. So trying to use more sustainable materials as much as possible because so again, paper is getting momentum, but some applications are limited for that. You can't use paper everywhere because mainly gas barrier, paper doesn't keep gas inside, So one of the things. Another point, we have new materials are coming up, biodegradable materials. But this is always challenge to put them in the market. It takes a long time, and you usually, that materials might have certain property problems, but it's limited to the certain segments. For certain segments, we're getting new materials. And another solution, this was a force, right? Using new materials. And the last one, I would say to use bio-based raw materials. So that raw materials we use for plastic manufacturing comes from fossil fuels, right? You dig from the ground the oil, you refine it, get raw materials, petrochemicals, and then you make plastic out of them. So, but there are some companies like I will mention name Origin Materials or Lanzotech. I really like they are using wood or as a raw material. They take it, process it, and make a raw material for PET plastic. So basically, it comes from the waste wood. Or Lanzotech, what they do, they're cool. I mean, they take carbon dioxide, which comes from the iron plants, feed it to the microbes eat it, and on other end they make useful chemicals. Then you can use elsewhere to produce other valuable things. So again, using less, recycling more, using new material, enhancing, using sustainable material, and using bio-based sort of raw materials. That's sort of different keys to solving this plastic pollution problem.
Mm-hmm. Going back to your existing clients and how it works, what is the implementation of changing their processes to use your additive look like? Does anything material change? And then are there any things that the workforce typically has to learn, or is it relatively straightforward?
There is, so the biggest highlight is that we don't need to have new equipment. So nobody needs to put the new equipment or change or make a significant changes. But there are some changes in terms of the process optimization. Let's say, for example, if you use certain process parameters at 300 bars, with our technology, you have to use 450 or 500 bars. Or you melt this plastic at 285. With our technology, you have to melt it at 295. So this kind of, or dry longer, so that there is a plastic drying period. You would normally dry it for 8 hours. The hours will have to be dried for 12 hours, for example, just saying. So as you can see from my comments, there are changes, but it is more about process optimization rather than going and buying a $3 million equipment.
Got it. Okay. So it's mainly just kind of changing the input and then changing kind of the management of the existing infrastructure. Yeah. Interesting. And then I guess you mentioned a few times other countries that are doing things well in the recycling of plastic space. Could you maybe speak to any regulatory things that you're seeing in the US or just more maybe abroad on what other countries are doing to actually fix this problem? What solutions are working from a regulatory standpoint?
Europe is, I would say, from the sustainability point of environmental point of view, is ahead of US. So they're more proactive with regulations. Some countries are banning single-use plastic in general. And what I like about Europe's countries like Germany, I lived 7 years in Netherlands too. They have incentives to basically go and recycle. I remember myself going to like Target, for example, putting bottles in the machine and getting a couple of cents for those, and that was widespread everywhere, basically. So people had the incentives, and that, Silas, adds up. Just adds up, right? So in US, new Plastic Pollution Act was, if I recall that, some time ago they made some announcement and about the new regulations on plastic, but I am not familiar with the details in terms of how they will reinforce it legally. California, I know, is more proactive among the states. They have plastic laws which prevents single-use plastic.
Interesting. That's really always fascinating to me. I think that I can't remember the exact example, but I know there are examples of kind of from a civil standpoint trying to incentivize people to change their behavior rather than punishing them, right, for bad behavior, kind of incentivizing good behavior. I think it's interesting to see some of those solutions. I really would be keen to see some of the more forward-thinking cities start to roll these things out, or for example, like you said, California, and see how effective these are. I want to shift a little bit to people looking to get into the space. What would you say for somebody who wants to get into this kind of advanced materials space and sustainable materials space? What, if you were graduating high school, what would you recommend for them to do? What steps should they take to enter into this space and prepare to be part of it?
So it depends. So if they want to work for sustainability, sustainable materials company, there are a couple out there, but they have to watch out which nowadays, it became too trendy to greenwash stuff, and even if you don't have so much sustainability impact, the people start claiming it because it became trendy. So watching out that the company you are joining has real sustainability impact. In terms of if they want to start own company, there are interesting researchers going on in several Berkeley, MIT. They have Berkeley. I know they have sustainable chemistry laboratory and so on. So if they want to do chemistry and they want to do sustainable chemistry into the field, if this person wants to specialize on something, so there are a lot of researches going on. They can join with those like the Berkeley Green Chemistry Lab, look at the technologies which come out there or join their research. MIT does a good job over there, especially focusing on green chemistry. So finding the right organization or becoming a part of the research which have a potential to be commercialized, that might be a couple of strategies they might take.
Interesting. I think that's very helpful. One thing I wanted to also bring up that came to mind when you mentioned biodegradable plastic solutions or things that are coming down the line. A while back, I had Peter Layden on, and we were talking about basically creating and engineering from the ground up kind of the properties of materials that we use to be, biodegradable within weeks or two, a week or two once they're used. How far out do you think that reality is? And do you think it is a reality that we can get to a point where we are able to basically engineer these products from kind of a use case cycle and thinking about the end of life, right? So if it's a plastic bottle, we know the intention is to be a plastic bottle. We can make it so it biodegrades in a week. And it can reduce some of these entire issues of actually collecting it. How far out do you think this is, and is it possible?
That's going to be a challenge. So, for example, biodegradable materials. There are some biodegradable materials out there. For example, PBAT or a couple of others. But PHA. The point is that usually these materials have some property problems. So they don't keep gas inside. They are not strong enough. The temperature, for example, when you melt something, you melt it at a higher temperature. Some proper materials degrade at 70, 80 degrees, and they don't get a chance to melt. They just degrade, These kind of things. So my point is that, yes, we have this perception about holy grail material which does this and that and this and degrades in 6 weeks. But I mean, with my humble background in chemistry, I would not think that. It's usually about trade-offs. So one material is biodegradable but doesn't have gas barrier. That's fine to use for some applications. One is like for PET, you need them to keep the gas inside, be transparent. That's fine. Then you use PET, then recycle it, right? So I know this sounds sexy and attractive to have this holy grail material which does everything and degrades, but usually it is trade-offs. My humble background said that having all-in-one, it doesn't work. It's hard to make it work. Mm-hmm. You have to compromise somewhere.
Mm-hmm. Yeah, that's interesting. I appreciate that. One thing I guess I wanted to also maybe pick your brain about is, do you have, you mentioned, for example, the Target option where people are kind of returning their bottles and receiving something. Do you know of examples that people can look to research to, especially anybody who might be listening, who's kind of a leader in their kind of municipality or city, on places that are doing a very, very good job and have a very holistic approach to kind of the circular economy? Because if we're going to achieve this, and if it's truly impossible to eradicate some of these kind of materials that cannot just biodegrade, how can we look at people want to help lead their communities to be very holistically oriented towards collecting all these materials so that can be returned and the life cycle can be as circular as possible? Any examples that you might cite for people to look into?
So The examples can be, again, Germany. I have seen a couple. I lived and worked over there too. So we spoke about collection, right? Then what happens, they have also tax credit on CO2 emissions, right? Sort of, that also matters. So the incentivizing and punishing, so sort of this kind of things. So, and once I was working at a major BASF, major chemical manufacturing, one of the things I was impressed, they have been using 90, it was a huge, the biggest in the world, the chemical site, and they were recycling 98% of the water. So basically, the raw materials or waste from this chemical plant would go to another chemical plant as a raw material. So there are some example cases which, so in terms of having these closed ecosystems. Again, Germany and the government over there is doing a good job, I believe.
Yeah, that's interesting. I really appreciate that. I think it'd be worth looking into that. I guess, I think we've talked about quite a number of things. Are there any other final thoughts or things you want to leave to the audience? Maybe, places that people can reach out to you, anything you want to leave us with?
So I just want to say that everything starts with us. We should keep trying to minimize our plastic pollution ourselves. For example, I never buy single-use plastic bottles. If I need to buy a spring water at home, I buy bigger containers, my water bottles. I have same water bottle for gym. I frequently refill it. So starting with us on one side, being everybody being aware is a part of the game. And if sometimes you go, every morning I walk in the park nearby. So sometimes it's about picking up the bottle from the ground and putting it in the trash can. So we are all part of this planet. So being a part of the movement and keep putting pressure on your favorite brands. I mean, and raising that, saying, hey guys, we want to use sustainable materials like paper or use less plastic, and basically making the wave we have now in terms of sustainability even bigger. And again, it comes as a consumers from the consumers like you and me, Silas.
Absolutely, I appreciate that. I think that's very helpful. It's also very great to see somebody kind of in the space who's not only trying to solve it, but actually, actively taking part in it on a daily basis on the small things, right? It's very difficult at times to do so, but I think it's very, very good example. But yes, thank you so much for coming on the podcast, and I'm really excited to see what you guys continue to do.
Great. Thank you for inviting me. It was a great pleasure.
All right, thank you so much for listening to today's episode. Please let us know what you thought of the show. If you have any specific comments you want to share, discussion points you want to continue, feel free to reach out to us. Again, you can reach me on Twitter or reach me through the Slack channel. Always glad to continue the discussion. And of course, please reach out to Bahruz directly to learn more about what they're doing at BERKM. Of course, we also ask that you share this with somebody who might find it interesting. If you are joining us for the first time, of course, if you enjoyed the show, please leave a rating wherever you listen, and of course follow along for more if you are interested in continuing. Just a quick note, our next episode will be with Eddie Badrina, who is the CEO of Eden Green Technologies. In summary, they are a vertical farming technology company, and in this episode we discuss the challenges of vertical farming, how they are approaching those, and how vertical farming can help decentralize a large part of the agriculture industry that will essentially help us become more resilient as a society as the effects of climate change kind of are felt more and more globally. So very, very interesting episode coming up with Eddie. Please tune into that on the next episode. And yeah, thank you again so much for listening and tuning into the CleanTechies podcast. We will see you next time on the show.